Unveiling the secrets of motion, Newton's laws. Welcome back to the channel. Today we're exploring the mind-blowing world of physics with Sir Isaac Newton as our guide. You know, the guy with the apple and gravity? He also gave us 3 fundamental laws that govern how everything in the universe moves. We're talking about Newton's laws of motion, folks. These laws are the bedrock of classical mechanics, and they're as relevant today as they were back in the 17th century. But here's the thing, we don't want to just throw equations at you, we want to make these laws come alive, show you how they're at play in your everyday life. So, buckle up, get ready for some mind-bending concepts, and together let's demystify these laws. Let's get started. Alright, let's kick things off with Newton's first law of motion, also known as the law of inertia. Inertia means objects like to keep doing what they're already doing. If it's sitting still, it wants to stay put. If it's moving, it wants to keep moving. It takes a force to change an object's state of motion. Imagine a game of cosmic billiards. Those balls will keep going in a straight line forever unless something steps in and forces them to change their path. On Earth, friction and air resistance stop things from moving forever. Inertia is why you feel a jolt when the bus suddenly brakes, or why you slide to the side when your car makes a sharp turn. The seatbelt provides that external force, keeping you safe. That's Newton's first law in a nutshell. Now that we've got a handle on inertia, let's crank things up with Newton's second law of motion. This law delves into how forces interact with mass to produce acceleration. And how do we do that? With the legendary equation, F equals sine ma. Force equals mass times acceleration. Force is any push or pull that can change an object's motion. Mass is the amount of matter an object has. Acceleration is the rate at which an object's velocity changes over time. The bigger the force you apply, the faster it accelerates. Think of pushing a shopping cart. The more force you exert, the quicker it picks up speed. If you apply the same amount of force to a heavier object, it won't accelerate as quickly. This law is at work everywhere, from rockets launching into space to elevators accelerating upwards. So remember, F equals sine ma. It's a fundamental principle that governs the very fabric of our universe. Chapter 3. Newton's third law of motion, action and reaction, the cosmic dance of forces. Newton's third law reveals a fundamental truth. Forces always come in pairs. For every action, there is an equal and opposite reaction. Think of it as a cosmic dance. Every push is met with an equal and opposite push back. When you push off the ground, you're exerting a downward force on the Earth. The Earth exerts an equal and opposite force back on you, propelling you upwards. This law is also behind how rockets propel themselves through space. When a rocket expels hot gas out of its engines, that's the action. The reaction? The rocket is propelled forward. Even walking involves Newton's third law. When you take a step, you're pushing backward on the ground. The ground pushes forward on you, propelling you forward. So, remember, for every action, there is an equal and opposite reaction. It's a fundamental principle that governs the interactions of everything in the universe. Chapter 4. Newton's laws in action, from everyday life to the cosmos. Now that we've explored Newton's 3 laws of motion, it's time to see them in action. These laws are constantly at work, shaping the world around us. Let's start with driving a car. Pressing the gas pedal increases the force applied to the car, causing it to accelerate. Hitting the brakes applies a force in the opposite direction, causing the car to decelerate. Ever played tug of war? Both teams are pulling on the rope with equal and opposite force. Sports provide countless examples of Newton's laws in action. A baseball pitcher uses force to accelerate the ball toward home plate. When a basketball player jumps for a slam dunk, they're using the ground's reaction force to propel themselves upward. Newton's laws are universal, governing the motion of celestial bodies just as much as they do a bouncing ball. The moon orbits the Earth because of the gravitational force between them. So, the next time you see an apple fall from a tree or a rocket launch into space, remember that Newton's laws of motion are at work. Chapter 5. Newton's legacy, the enduring impact of 3 simple laws. As we wrap up our exploration of Newton's laws of motion, it's important to reflect on their profound impact. For centuries, they served as the bedrock of classical physics. Newton's laws allowed us to predict the motion of planets, design bridges, and even send humans to the moon. They gave us a framework for understanding the physical world. Newton's laws sparked a scientific revolution, inspiring generations of scientists. Of course, no scientific theory is perfect. In the realm of the very small, quantum mechanics takes over. In extreme gravity, Einstein's theory of relativity provides a more complete picture. But Newton's laws remain incredibly useful and relevant. They are the foundation upon which we've built our modern understanding of physics. So, let us celebrate the legacy of Sir Isaac Newton, a man whose curiosity and genius unlocked some of the universe's greatest secrets. And that's it for today. If you enjoyed this breakdown of Newton's laws of motion, make sure to hit the like button, subscribe, and share with your friends. Leave us a comment with any questions or other physics topics you'd like to explore. Until next time, keep questioning and keep exploring.